About a year ago, I had an idea to build an indoor water feature. My initial thought was to bore a hole in a rock and create a bubble rock. But as ideas go, sometimes they just get bigger. This idea grew from a small bubble rock to a waterfall built into the wall. Running along the street in front of our house is exposed bedrock. This, I decided, is what I wanted to recreate, but adding flowing water to form a waterfall. Since a lot of rocks had sloughed off over the years, this gave me plenty of material to use. Over the course of running the waterfall for a year, a couple of issues came up that I needed to fix. This video shows how I did the initial build of the waterfall and then the steps I took to fix the issues. To increase the overall atmosphere of the waterfall, I also added a fog effect. So let's get to it. Starting this project, I immediately ran into a couple of minor issues. The wall where I wanted the waterfall was load-bearing, so I had to add a header. As well, since the wall backs into the garage, I needed to add a foundation to keep the framing off the floor. I realized at this point this was not going to be a simple build. After framing in the area that will hold the reservoir, I ran the electrical for the water pump and lights. These will be controlled by switches on the front side of the waterfall. The reservoir I am using is a 27-gallon bin, or 102 liters if you're from Canada like I am. The pump I am using moves water at 2,200 gallons per hour, which will be more than I need. Since it would be impossible at this point, or really at any point, to calculate how much water flow would be required, I just picked up a larger pump. To keep the pump operating at full capacity, I plumbed in a loop using a ball valve to relieve any back pressure. This bin will be used to capture and return water to the reservoir. It will also be the platform for the entire water feature. I have formed concrete around the PVC, which will be used as the water source for the bubble rock. So no, I never did give up on the idea of building a bubble rock. It will sit in front of the waterfall to enhance the overall effect of the water feature. Since the entire waterfall will be built using real rocks, I added blocks to help support the weight. With the bins now in place, I carried on with the framing. To support the rocks that will make up the waterfall, I added backing using plywood, then cement board. I then covered it with tar paper. It would seem I got a little ahead of myself at this point. After adding the backing, I should have started framing in the sides. For reasons I cannot explain, I skipped this step and added the lath and scratch coat. Other than adding a couple of hours of unnecessary work, this didn't cause any problems going forward. Now that the sides are framed in, I began adding flashing. In designing this waterfall feature, which I mostly did in my head, waterproofing is what took the most thought. I can't emphasize the importance of this step, as finding and fixing a leak after the fact would be near impossible. After completing the scratch coat, I installed stone flats to the sides. I was now at the stage where I could build the waterfall. I started off using mortar to attach a few larger rocks, then filled in the gaps with smaller ones using a product called Instant Bond. The process was like putting together a puzzle with no finished picture or pre-fit parts. Sometimes I was able to fit a lot of rocks in place, and other times where I was out exploring for just the right rock. It was a long process, but it was finally starting to take shape. Now I was at the stage where I needed to add the water supply. The goal was to have water flowing over as much of the rocks as possible. To achieve this, I used flexible PVC to bring water to multiple areas of the rock wall. After about 10 days of placing rock, I was ready to move on to the next step. After cutting 3/4-inch plywood for the ledge, I wrapped it with tar paper, and then when I installed it, I sloped it a few degrees inward. I then attached drip flashing to the inside edge, as well as angle flashing to each side. After this, I added a liberal amount of roofing tar, filling in any gaps. Before I attach the lath for the stone, I will add more tar paper, covering the flashing edge. The manifold shown here is what will be used to control water flow to all the different areas of the waterfall. One of the PVC lines in this image comes from the pump, and the other 5 lines provide the water that will make up the waterfall. When I tested the water flow, I noticed a dry area, so I split one of the water sources into 2, directing the water to that area. After testing the water lines for leaks, the next step is closing in the backside of the water feature. Because this is the garage, I insulated all air spaces open to the house interior. For the same reason, I added a vapor barrier, creating an airtight seal. I then finished it off by attaching plywood and OSB. During the framing stage, I added 3 access panels. This one in front is for being able to remove the reservoir for maintenance. The one on the side contains the power for all the lighting and fog effects. And the top panel is for access to the fogger, lights, and waterfall. The waterfall feature at this point was close to being done, but before continuing, I wanted to finish off the stonework. Other than the area just above the waterfall, installing the stone was more or less straightforward. After about 10 days of stonework, I was ready to move on with completing the waterfall. I thought at the time that I just needed to turn the pump on, make a few adjustments, and have this great-looking waterfall. It did not work out that way. Some of the areas of the waterfall did look great, but other areas had water dripping off rocks. Not only did this not look good, but it created splashes outside of the waterfall area. To fix this, I needed to add small rocks to help divert the water, eliminating the drips and splashes. This turned out to be a very tedious and somewhat annoying process. It involved finding and placing a rock with the waterfall was running, turn the water off and let the area dry, then finally gluing it in place. What was annoying was when water connected to my finger and ran down my arm. After many hours of this, I finally had a working waterfall. It has been a year of using the waterfall, and thankfully there were no leaks, but there were a couple of issues that I needed to fix. The next part of this video shows the fixes, as well as the building and installing of the fog effect. If it is not too obvious, filling the reservoir is one of the issues. Actually, let me rephrase that. Filling is not the problem, but when and how often I needed to is. To demonstrate, I ran the waterfall for 24 hours, recording the water level before and after. Before the test, as you can see, the water level is at 10 inches. Then after 24 hours, the level dropped to 9 inches. I anticipated there would be some water loss, but not 1 inch in 24 hours. I did figure out I needed a float valve shortly after finishing the waterfall, but here it is a year later, and I'm just getting around to installing one. I cut a hole in the side of the reservoir, making sure I could use the bottom lip of that hole to support the float valve at the right level. I then cut a hole in the framing, lining up with the hole in the reservoir. On the outside of the framing, I added support for the pipe coming out of the reservoir, making sure it was level. Then I connected a union on the PVC pipe between the in and outside of the reservoir. This is so I'm able to remove the reservoir for maintenance. As a final step, I ran a hose from the garage water supply to the pipe leading into the reservoir. The next issue I had was with the waterproof LED strip. After several months, the lights exposed to continuous water failed. Apparently, waterproof does not mean water submersible. So the LED lights needed to be replaced, which meant removing everything at the front of the waterfall. But this provided me with the opportunity to do something I'd had in mind, to create a fog effect both at the top and bottom of the waterfall. Starting at the bottom, I needed to build 2 containers to hold the foggers, one for each side of the waterfall. Using 2.5-inch acrylic tubing for this, I cut 2 pieces at 2 inches. Then using the tubing, I traced onto 3/16 acrylic to use as the bottom. After cutting out the bottom, I was ready to bond it to the tubing. To do this, I'm using a product called Weld on 4, which is a bonding agent that literally welds the 2 pieces into one piece. As you can see, this water-thin solvent wicks between the joint. Then a chemical reaction occurs that will melt and merge the material. The initial bonding happens quickly, but it will take a couple of days to fully cure. After waiting a couple of minutes, I apply pressure to the joint. This will ensure there is full contact between the 2 pieces. In an hour or so, the bond should be strong enough to work with. Here, I'm using a 2 1/4-inch hole saw to cut a hole in some acrylic. This piece will be used as a lip to support the container. In this clip, you can really see the weld on wicking into the joint. Here I will be cutting a hole in some pond liner. This will be used around the acrylic container to help divert water into it. Using a 2 3/4-inch hole saw, I will now be cutting a hole for the container that will hold the fogger. Now that the foggers are in place, I can now add the new submersible LED lights. I use silicone here to keep the light strip pointing upward. I then added clear glass stone to cover the entire area. This will give a nice effect by dispersing the light. I then staged the area with an assortment of rocks, as well as these metal spheres. I thought it might look interesting with the spheres over the foggers, but I won't know until everything is turned on. After finishing with the staging, I moved on to the upper fog effect. Off camera, I built a box with a bulkhead to bring water in and one to vent fog out. I am using 3 foggers, hoping that will be enough. I cut a large hole in the top so I would have access to the foggers, then smaller ones to allow air to vent in. This should allow the fog to drift down through the bulkhead. After adding some weight, I bonded the top to the box using a syringe and needle as an applicator. To test the foggers, I added enough water so they are totally submersed. I then set the top in place, covering the large access hole. After this, I plugged the foggers in. To disperse the fog over a wider range, I added PVC pipe with holes in it. As a bench test, this seems to be working as I hoped. Now it's time to mount the fogger at the top of the waterfall. Before I installed the fogger, I realized I forgot to add a drain. It's probably hard to see, but I added one next to the bulkhead. With the upper fog effect in place, it is time to see how the finished waterfall looks. I hope you enjoyed this video. If so, please hit the like and subscribe button. If you do, I thank you. Also, I appreciate any comments or feedback, which you can leave below.